When we have the minimal valuable tensor, from now on, let's switch to the practical based approach. We need to create something useful, yeah? And I suppose that the best way to learn the backpropagation is to create a neural network. So the foundational class for every neural network is the parameter class. We can create the parameter as the children of the tensor. Okay, and let's define the constructor, and we receive the bunch of arguments self. Then we have the shape as the tuple of integers, data. Probably for some tricky initialization you want to, I don't know, initialize data by your own, yeah? But we will cover the most important cases. And let's install this data as the optional, maybe numpy and the array. By default, let's init it as none, and init method. I think that this is really necessary. It's very important parameter. By default, let's initialize as the normal. And probably let's import the literal data type and init the possible init method data type as the literal with this bunch of initialization method. And let's utilize the Xavier by default. If you wanted to know more details about the parameter initialization, you can check my video where we built this initialization and where I described the mathematics behind the initialization. So if our data is none, we need to call the data initializer, and in our case we can create a method, let's say init, and push the shape and init method, and also let's add one more. Let's call it gain. Define it as the float data type and init to 1. Okay, and push this gain to the init method. And then we need to define this init method. We receive self, so shape. So the shape is the tuple of integers, and same init method and gain. Okay. In this case, let's create the init method data type as this literal, and as mark the data type like this. I think that it would be more nice. Okay, and for the hierarchy we need to add the alpha parameter. We need it as float, by default 0.01. Again, I just don't want to go deeply into the details because I have the whole video about the weights initialization. You can check how this initialization works and what is the parameter alpha for the leaky here. Here we need to do one more step. We need to call the parent constructor init and push the data as the initialized data. And I think for the parameter in our neural network we always need to track the gradient. We need to switch requires gradient to true. Yeah, we are ready to move on to the next fundamental class module. We prepare the forward method for the module, and we receive self and the bunch of input as any, and we need to return the tensor, or let's just drop any, it will be fine. Just because this is the parent class, let's raise non-implemented error. So, okay, this method is absolutely necessary to implement. I want to follow the same API as inside the PyTorch. And we need to create the call magic method, and we just build a proxy for the self.forward and push the arguments and arguments to the forward. And we return the same tensor data type for the call. Inside the module, we track the parameters that we have for our neural network. So let's import or from typing import the iterator data type. And I want to create a method parameters, and we receive self, and we return the iterator of parameters. Okay, and what we need to do, let's create an iterator item in the self dot dictionary dot items. By this way we iterate through all of the properties of our class, and then we check if is instance of item is our parameter, we just yield the item. So we make an iterator, and for every call of the next method or for every new iteration in the for loop, we return this item. So, and if we have an instance for our item as the module, we can yield from item dot parameters. So if we work with the module, if this item is module, we yield from the parameters of this module. Yeah, do this recursively until we reach the bottom of the modules stack. We need to also implement the zero gradient method. We have self as the argument. We return nothing back, but we need to call for param in our self dot parameters, and we will call param dot zero gradient. So when we call the zero gradient for the module, we call the zero gradient for every parameter of our model. So that's basically everything that we need for the module class. Let's run this code. One more useful class is the sequential class as the children of the module. This class can help us to build the deep neural networks. For example, we combine together several modules and make them work as the whole. So let's create the init constructor. We have self, we have modules as the modules tuple as the module data type, and then we need to initialize the parent constructor, and add to the modules our parameter, our argument module. And then let's define the parameters method, and we need to return the same iterator of parameters, but compared to the previous implementation, let's make a loop for every module in self.modules, and we just yield from module.parameters all of the parameters for every module, everything that we need for the training. And let's build the forward inside the sequential. Okay, let's create the for loop, and by the same way we do the for loop for every module, then we call the module, provide this input like this, and then override the input and return the input at the end of the computation. So we call the input, we call the module, provide the input, override the input, and return the input at the end of the computations. Okay, and I think that we can return not only one tensor, maybe we run and return like several tensors or whatever. Let's just drop this return data type, yeah, because we cannot be sure what type we will return back. I think that we can stop here because we implemented the high-level components. We prepared all the necessary pieces to build the real neural network, and we will do this in the next video.